All right. Hello, everybody. Welcome to the Megaport Tech Drop-In for this Friday, the 25th of October, 2024. It's us, Megaport Live. So we're going to be covering a couple of topics today that have actually come up in some of our recent conversations with the solution architecture team. So firstly, I'll start with a quick overview of myself. So Jason Bordajenko is my name, or JB is probably easier. I'm the head of solutions architecture here at Megaport, based in Brisbane, but looking after the Asia Pacific region and time zone. Where you can contact me, easiest is probably jb@megaport.com. Or find me on LinkedIn. Absolutely happy to have a conversation with you. As I mentioned, the Megaport Solution Architecture team more than happy to work with any of our customers that are looking to architect particular solutions or questions. And these webinars that we run each week on a Friday, 12 o'clock Brisbane time, so AEST. We don't do the daylight savings dance here. More than welcome to join in for 30 minutes and see what the most recent topics are. We cycle through some vendor updates, we cycle through some product updates, and also just generically do a bit of an overview of the platform. And it's a getting started, where do I get started type presentation for a lot of customers as well. So with that in mind, I would like to kick off on a couple of introduction slides, and then we'll dive into the specific topic for today, which is regarding AWS and Direct Connect in particular. So firstly, the Megaport proposition is we're a globally available neutral service provider or agnostic service provider, and we run a global network infrastructure and effectively linking all of this infrastructure and the deliverable product is known as the Megaport SDN, or the software-defined network, and they're the principles with which we operate that network. And what that means is it allows our customers to have very fast, within minutes, flexible and on-demand connectivity to services that are available globally. It might be, within the same data center as they're in. It might be within the same metropolitan region, or it might be going across states, across continents, or in fact across the globe. And it's the same principle that connects each of those products in our service suite, which I'll show on the next slide. But this overview here gives an example of not only the data center brands that we're resident within, and you as a customer don't necessarily need to be resident in that DC. It is possible to consume some of the services over the internet. Internet is also a product that we sell to customers, but effectively the on-ramps, the target locations that our customers wish to go to, that's what makes up the main components of the proposition that we have and what we deliver to our customers globally. So we're now at about 900 data center locations. I'm going to update this slide. It says 800 there. That's counting those that have physically got Megaport equipment in them, so-called enabled locations, and also locations that are easily connected to those that have the active equipment using things like a campus cross-connect or another unlit fiber service. So these are our extended locations, and they're counted within that number as well. It is a continual update. It is always being refreshed with new data center locations coming online. So if you would like to get a list of where that is, best to either log into our portal or just do a search for Megaport enabled locations, and that will become available to you, and you don't even need to log in to get hold of that. So let's talk very much at an overview level of the Megaport product portfolio. So we term our products pretty much into two main categories, which is access products that we see on the left-hand side, and then the connectivity pieces on the right-hand side. And they're the components that can be utilized from those access products. So in general, a port, what is that? A Megaport, and it's very much in the name of the company and the product itself. This is a physical interface. This is a Ethernet speaking interface. Generally, it's going to be single mode optical SFP that's required. And we have three standards of connectivity speed there: 1 gig, 10 gigabits per second, and 100 gigabits per second. Not all data centers have 1 and 100 gigabit per second connectivity, but I would say every data center that we have in that list would have 10 gigabit per second connectivity. This is, in its simplest form, a single port, but it is possible to build highly available and highly resilient networks that traverse all of your production traffic as well. And we've got multiple ways to do that. Look, I'd be happy to take questions on that after the presentation. It's not the key thrust of today, but it is possible for us to deploy multiple ports in many different ways. So we can configure them in a highly available or highly redundant fashion, even within a single data center, though it is quite common for customers to look at blending products across different data centers as well. There are two virtualized products for customers that aren't physically located in a data center, and they are the Megaport Cloud Router, which is termed MCR, and Megaport Virtual Edge, which is MVE. And I'll talk about those briefly before we move on to the connectivity elements. These are complementary to a port. They don't actually require a port to operate, but an MCR in its simplest fashion is really a hosted routing instance. It's not that we're going in and providing you a full root level login to a specific routing platform. We're giving you via our portal an easy to use component that is able to be spun up again in a matter of minutes globally, that would then be able to connect to any of the resources that are on our network, whether they were sitting on a customer port or whether they were sitting in one of those on-ramp locations, such as a cloud service provider. The most common scenario that we see with MCR is actually to join two cloud service providers together that are different brands or different regions, in fact. And what that does is it allows customers to utilize things like private peering. So they're able to connect to their VPCs or VNets. It depends on which cloud you're in as to which terminology is accurate there. It allows them to connect that to other VPCs or VNets, again, different clouds or different locations, pretty seamlessly, in that it doesn't need to go via a NAT translation gateway. It's using private address space and can stretch that VLAN effectively between those two networks and keep it as close as possible as the midpoint of those two as well. So you're not taking the network traffic on a longer journey and obviously adding latency and risk to that as well. Now, for customers that have used MCR or are interested in it, there's up to 25 virtual cross connects, and we'll talk about that very briefly, able to be connected to a single MCR. As I mentioned, that's a managed platform on our component. For customers that have actually gone beyond MCR and either need different levels of connectivity or different vendors, or in fact, they need to gain that full root access, they need to have that controlled environment for routing, they can actually now launch an MCR-like environment in our platform that's known as MVE, or Megaport Virtual Edge. And MVE supports a large number of different vendors and running their particular component or software component on our network in those locations that we provide that compute and connectivity for our customers. So generally, an MVE will fall into one of three categories. The first one I've already described, which is as an adjunct from MCR. I just need a router, something that can route traffic, but obviously do so, maybe joining in internet circuits in that as well, but generally off the internet in more private type connectivity. The second one is in a security landscape where we have customers that are using it for hosted firewalls or security inspection appliances. So that's actually quite a common and emerging use case as well. We have a number of vendors that make that available on that platform. And the third and final one of those three is to utilize the MVE as a bit of a hybrid role. So it's a router that it's quite specific, and it may be doing security function as well, but that is a SD-WAN gateway. So to bridge customers who are on the great unwashed internet, to put them into a data center that we know and trust and collect them from the internet using multiple tier one service providers, but the ability to then actually hop onto the Megaport network where we provide that private and high bandwidth connectivity as well. So I mentioned that that is generally a use case for those that are blending SD-WAN connectivity. They may already have some SD-WAN head-end type capability at one of the head office sites, but it allows that to be brought back to a data center, even if that customer does not have space and power requested at a specific data center, that they're actually able to use Megaport to do so. So those three components define the access product overview. And then we move over to the right-hand side, which is connectivity. And I've already teased there on VXC, or Virtual Cross Connect. And that is a layer 2 connection, or a VLAN, and it can extend between any of those different access products we spoke about. So a port to a port to an MCR, or let's say an MVE to a port as well. Any of those combinations can be taken up there. Now, we speak about that generally in terms of what is the target or what is the reason for that VXC. And the most common is going to be a private VXC, but another one that would probably come up in terms of what we're going to be covering today is a cloud VXC. So it's not necessarily going from a customer port to another customer port. It's a customer port that wants that, blue string, as it were, the Ethernet replacement connection, but they would like to plug that into a cloud service provider and a cloud region and have some sort of high availability across that as well. I mentioned that we do provide internet access, and that's a very large and emerging area that I believe is probably worth another drop-in topic. So if you're interested in that, please throw that into the Q&A, and we'll come to that and take your nomination on that and let you know when that would be available. Another one that we provide is our internet exchange service, and this isn't actually a full internet. We think of internet exchange as a series of switches that exist, and they're effectively all linked together natively in a VPLS environment or a multi-party connectivity. There's no need for individual VXCs, and any of the participants on that internet exchange that are exchanging those otherwise internet-facing routes would get a full next hop high availability connectivity into those peers on Mega IX. Again, probably a topic for another day. But utilizing those components, particularly VXC, allows us to then make available other services on the platform. And the ones that we call out in particular, one on the bottom right is the service key. So whereas on the left we have ports, MCRs, and MVEs that would exist within the portal of a given Megaport customer, it may be that there's a B2B need. So a customer wanted to connect to someone else that also has a Megaport. It is possible to do that as well. A couple of different ways for them to do that is that the customer who wants to receive that connection can actually list their port as public, and that will place it on our marketplace, and obviously customers can discover and connect to those resources quite transparently. Again, they're utilizing the VXC component to do it. The other one is where it's a bit more private. It is for a bespoke need or a specific customer requirement that's in an industry where it's not advertising the full availability of those ports to collect end user connections. And we do have the capability to issue a service key, which is a one-time or multi-time right for a third-party customer to actually create a VXC towards another destination on the network. So again, is a whole overview of the access products and the different methods that it is possible to access within the Megaport network or through the Megaport network. And then the stitching together of that is effectively with VXCs and everything that we build on top of that as well. Now, I mentioned we're going to talk primarily around cloud VXCs today, and I'm aware we've got a limited amount of time with half an hour and hopefully allow a few minutes at the tail end for questions. I have certainly seen an uptick across the APAC SA team in the last couple of weeks of requests around AWS, and particularly in relation to encryption. So I wanted to take a minute to talk to this audience that we've got joining us today around AWS Direct Connect and how that compares to what's traditionally been used with a site-to-site VPN or an IPsec connection. Now, IPsec VPN connections or their tunnels are a great solution for customers who want that level of security that they're not able to get otherwise over the internet when accessing their cloud environments. So it does satisfy that immediate need. I will cover that when I say low to modest bandwidth requirements. We'll come to that in a future slide. We don't see customers generally pushing above 800 or 900 megabits per second of throughput on those links when they're utilizing the built-in services. It does find more use where the application would deal best with variability in latency, which is otherwise known as jitter. Even for short hop connections, because it is a platform-based service, it is difficult to troubleshoot if you are doing voice or video applications and you're using IPsec. There can be many layers of the stack that actually can be impacted. And obviously those third-party carriage components that are between the 2 points, it says site to site, so between where the customer resides and their end of the tunnel and the cloud end of the tunnel that they're using, there can be multiple hops, and some of them are well out of the control of either AWS or the end customer themselves. Another one to consider is the encryption type. Just because we're talking about IPsec here, it is a standard, but within that is an umbrella of different encryption protocols that can be run. So it is important to consider that in security contexts, the lowest common denominator that is agreed on both sides will be what is achieved. So if you can imagine an IPsec connection that's being stood up a negotiation will happen between, obviously, we're talking in this case, AWS and the IPsec service that is running there, and whatever customer device or whatever customer software client is being used. When those two communicate and share the authentication information, they will then share a handshake to say, what protocols do I support? And of course, as I mentioned, if one is not, say, a more modern hardware than another, it would fall back to potentially at-risk protocols to be considered there. It is generally available to see what is negotiated or to find a list and figure out what would be negotiated. But I have certainly seen connections that have fallen back for other reasons as well, to lower grade connections, lower grade security connections, which can cause issues if you've got to get a regulatory tick in the box. Another thing, and I mentioned here, could be hardware or it could be software. We're starting to see the advent of specific silicon that is available to do encryption at a certain line rate. Now, I mentioned in the second point the bandwidth requirements and a consideration, and this will come back to this in a second. Generally, hardware will be scoped. And cost as well would be a consideration here. If you're just going beyond a general purpose CPU, the cost that is actually utilized to get something that can specifically offload encryption and do that in a piece of silicon in the device that is readily tailored for that particular component that is needing to be encrypted, it can have a higher throughput capability than the actual platform you're connecting to. So much like the fallback on that specific protocol, we might actually see something that is well over spec in terms of hardware, but unable to achieve that throughput just as a limitation of the particular IPsec implementation that's being used. And I've covered on jitter before, so I won't labor the point on packet delays, but this can be in consideration too. If there's not tailored and specific hardware, it is offloaded to a software like a CPU, and that is inherently based on the workload that's being run across that. Again, voice and video may be taxing that particular software, so that when adding a layer of encryption, if it's done, it's not being offloaded to hardware, it can in fact even influence it further than just the path itself. So this brings us, as I mentioned at the last point, to AWS Direct Connect, and this is something that we do provide via Megaport, but it does give us a couple of other options that some customers are interested in. One that I'll mention just before I do get into the slide that I'm not covering in today's presentation specifically is MACsec. And I know that we've had some inquiries as well from customers, can you support MACsec? And the answer is, actually we can, but it's not using any of the components that we're discussing today. It's utilizing what is known as a direct direct AWS Direct Connect connection, or dedicated DX connection. And the dedicated connection means that you would actually procure a physical AWS port instead of using the already available on-ramps at the locations that Megaport are available. So it's a little bit slower to get going. A VXC can be used in order to access that, so it can span geographies. It doesn't need to be within the same metro or the same data center, but I would certainly have a chat with your friendly solution architecture team or your sales team if MACsec is a specific requirement. This presentation today is to look at other options that may be available and consider those in terms of what is the light that we need to shine on it to figure out what's right for customer applications. So this first paragraph that I've got here in italics is actually taken from the site-to-site VPN connection guide for AWS, and noting that the site-to-site VPN is provided as 2 tunnels, and each of those tunnels supports a maximum throughput of up to 1.25 gigabits per second. So when I said before about 800 or 900 megabits per second, that's generally what we see with the overheads that are inherent in the protocols that are being used over the internet. If that connection is to a virtual private gateway, it is possible to aggregate. So obviously a site-to-site connection being 2 of those could get us to 2.5 gigabits per second. Real world, just over 2 gigabits per second. It is possible in that next paragraph to actually choose to balance that traffic, and the protocol is known here as ECMP. It's utilizing the ability to actually balance that multiple streams and multiple components and break that down across different transport pathways. Now, whilst it is possible to do it, it's probably not ideal in a lot of scenarios, because depending on the throughput that you're actually managing, and then going back to particular security protocols or being managed in hardware or software, we might start to see challenges in doing that. So today's presentation is to talk about what else can be done. So we do have the option of connecting via a private VIF, whereas the IPsec VPN is via a public virtual interface or internet. and connecting that to an Amazon virtual machine or EC2 instance, and noting that the available sizes and scales, and again, the software or hardware offload for encryption can be done. And we're starting to see customers building out some pretty advanced connectivity options using that without needing to then balance across ECMP. So before we get into the demo, I've got two more slides. The first one is to look at those different types of connections. Now, I will touch on hosted connection versus hosted VIF. I won't talk about hosted VIF at length today, but you will see that when we come into the portal. I'll talk about the types of connections from the AWS perspective. And the first one is the public endpoint or public hosted VIF. Now, the component there with public, that's actually what customers would be using if they're wanting to cut across a site-to-site VPN. Instead of using that over the internet, they wish to use that over a direct connect. It is possible to utilize that over a direct connect. You're still going to have the inherent 1.25 gig limitation, but you're going to skip some of those internet component or untrusted path pieces. The other access method would be used for this is for something like S3, where we're actually accessing public IP endpoints that are otherwise available over the internet, and it's exactly the same with the IPsec termination in that platform-based service. When we start talking about private connectivity, probably no shock, these are more like LAN IP addresses and they exist within customer VPCs. And that allows us to do things like hybrid cloud deployments. The common component here would be, let's say, an EC2 instance. Yes, it has a public IP on it, but we could actually expose that internally to a VPC with private IPs, and using a private hosted VIF in this case, it would be able to access at a higher speed, and it can be up to 10 gigabits per second. It would be able to access that higher speed connecting in directly into that EC2 instance and not traversing any of those NAT gateways, etc. Now, the third one is to talk about briefly. It's a different component. It's not available on hosted VIF. This is only available on hosted connection, and it's the transit VIF type. And that gains you access to the transit gateway that is a decision point for where that traffic would actually terminate. So the transit gateway would then hand off to a direct connect gateway, which would hand off to the VPC in particular. Now, a couple of just quick components of what you need. For a private connection, it's actually your own, I'll call RFC 1918 space, 192, 168 or 10 or 172. And that is probably already existing in the AWS VPC. So you just need a range that doesn't clash, and those two will be able to talk together. You do need to have a device that's capable of speaking BGP, but in that slide where we showed the access methods, MCR and MBE can be a component that will actually speak BGP for you. I'll move on to public, which is where those IP addresses need to be issued and allowed to be used by you. They need to be issued by a specific registry, so ARIN or APNIC. And then they are given to AWS to use for a particular peering. They are generally 2 of /31, so a couple of pairs of those public IP addresses. And then any of the customer side range, whether it be, one or multiple of those public IPs, are advertised to AWS, and AWS take the ranges that are available within that region and advertise them towards the customer. For customers that don't have them or can't use the ranges that they do have for particular reasons, it is possible for Megaport to jump in the middle when we're deploying something like MCR, and we can actually provide that for you. And I mentioned the NAT gatewaying before. So a customer that wants to build a public-facing VIF towards AWS can do so, but still take advantage of that private peering on their side. And this is the last slide before we get to demo time, and a couple of pointers on where to find this, which is the BGP configuration details. So AWS have some specific requirements that are available, and they do publish this. All of these are baked in by default to MCR when you spin up a connection. BGP itself is really just a protocol to exchange those routes. So it does need at least a link address. So 2 IP addresses on either side of that connection, being a VXC in this case. These components and these particular timings can be tweaked, but in general, they're going to again fall to the specific requirement of the task at hand. And the interesting one for us is actually BFD, which allows a little bit of a faster failover. So you can see the hold timer here, default hold timer is 90 seconds. Minimum hold timer is down to 3 seconds. With BFD enabled on a link towards AWS, we can get down to the 300 millisecond type interval, and then we can see the multipliers that are available to that. So within 1 second, we should start to see any particular failover go from a primary to a standby path. All right, so I think we've covered the main components. I will now touch on one piece, which is to look at our documentation. So within the Megaport documentation, if you do a quick search for AWS Direct Connect, you'll see some diagrams. I haven't replicated them on the slide as they're more of a takeaway from today's presentation. Firstly, I didn't mention too much about the hosted virtual interfaces. I spoke more about hosted connections. We can see here that we actually support a VXC speed of up to 25 gigabits per second. It's dedicated bandwidth. It's not shared bandwidth. It supports transit gateway. The only consideration and differentiation other than the speed and the transit gateway support is that once it is deployed, that speed is not able to be changed. It's not flexible. Whereas with hosted VIF, we can move it up or down. We do have customers that can make and break their connection. So they might make a new connection at a different speed, higher or lower, before break, which is then to terminate the old one. So given that it's only a couple of minutes to deploy one of these, and that's what we'll get onto now, it is quite possible to have a speed change and then use things like that BGP failover. And the last one is to touch on these dedicated connections we spoke about, where MACsec might be something that we can have enabled for you. But let's go and build one. If I jump into the portal very briefly, we can see those three access products, so port, MCR, and MVE. In today's case, we're just going to look at building it from a port, and this is the APAC special, so I'm going to pick the Australia data centers. And if we have a look here and see a particular data center that might take our eye, we can see the aggregations there, the different brands. I might pick Global Switch here, just in Sydney, and then we can see what of those port speeds are available at that site. And I mentioned there 1, 10, or 100 gigabit per second connections. Let's just do a 10 gigabit per second connection. Give it a name. We can then set a term, either month to month, 12, 24, or 36 months, and you can see we're applying a discount for that. And in terms of the diversity, I mentioned that very briefly as well. We can build at certain data centers what we call red and blue zone, diversity zone deployment. Now I'm just going to build one. You do have an option after to come back and say diverse from existing port. So let's go and build that port. And I'll click on order, and that will place the order for that specific port. Whilst I'm doing that, I have actually logged into AWS and I have an account ID, which then allows me to speed through the next step, which is actually building that AWS connection. So here I would choose AWS and I get to see hosted VIF ports, hosted connection ports. We've spoken a lot about hosted connection today. So by selecting the destination country, in this case, Australia, I can see that I can build from Sydney into Sydney, and there's multiple AP Southeast 2 appearances. So there's Equinix, a red and a blue, and there's Global Switch within Sydney, which is the facility that we're in, again, red and blue. This particular customer is actually wanting to stretch out into the Melbourne region, which is AP Southeast 4, and that is also supported. Now, I have mixed diversity zones here. That's not really going to cause me a problem because we're in 2 different metros. If I was doing it Sydney to Sydney, I would be trying to match that just to give me that little bit extra diversity. So it's no harm to do so, and you'll see that come up when you presented with a port, an MCR, or an MVE. So again, we're going to use the default JV drop-in, and then we're able to select a rate limit. So we can see we can go all the way up to the speed of the port, which is 10 gigabits per second, or down to the minimum here, which is 50 megabits per second. And we're given, again, that chance to put it on a term or select month to month in this case. And then I copied this before, but the ability then to use an account ID will launch that specific request into the AWS account ID that's active here. All right, so we should hit order on that. And whilst that is deploying, I'm going to go and check. We do have Dave holding out to see if there's any questions. Dave, yes, if you have any questions, please drop them in the Q&A panel. More than happy to tackle them. I have had one that has come in. Let me just grab my screen. And the question was in relation to having a link aggregation group. Does that make the connection more resilient? And the answer is actually, surprisingly, that a lag itself does not make the connectivity at AWS more resilient. It does allow a path failure. So something like a cross-connect failing, getting crimped in a rack, or a optic that's dying. But in terms of the Megaport side, a lag, which I didn't actually go into in the specific component that we used for ordering there, a lag will actually deploy on a single device within that rack. So it's not a multi-chassis lag. Using that diverse connectivity in different zones is actually the way to build that particular requirement in a highly available fashion. All right, so we are going through and building this connection in real time. As I mentioned, it's going to land into AP Southeast 4, which is Melbourne. Whilst we're finishing up and waiting for that, and as I said, I'm happy to take if there's any other questions. We do have for that specific port the LOA, which in this case, in the facility and global switch, takes us down to a specific rack unit, a specific latch of ports, and then port 9 and port 10 that are across that as well. So this customer would come in and hand the LOA to the data center, make that connection physically to their equipment, and obviously then we can start building those services. And just as I've been talking, that service has actually come through, and we can see that this is handed off now all the way from Sydney into Melbourne. And myself as a customer would simply say, yes, I want to accept that, and then build one of those three types that we spoke about of virtual interface. A private, a public, or a transit virtual interface can be built in that screen. So that does take us to the end of the presentation. I will go back very briefly to the contact slide. If you did want to get in touch, please absolutely reach out. We do run these sessions every week. As I said, we're always looking for new and interesting questions and comments to put to the team. But otherwise, I thank you very much for joining. Certainly, you are, whether you're coming through LinkedIn or you're coming through any of the modalities, if you're coming through Zoom as well, we are able to reach back out and send you the recording. We are placing them onto YouTube to make them available, but certainly want to hear what you'd like to hear about in the future. So please join us again next week or a time in the future. Thanks very much.